conclusion. In this chapter, we discuss the basic concept. We try to make this concept more accurate. We have introduced the lamp and the distribute, and time invariant, linear, nonlinear. And then we discuss active, passive. We have discussed the non-loss and the loss. And then we discuss the non-energetic and the energetic. And then we discuss reciprocal result. All these concepts have some difference with the undergrad course definition, and the active passive is emphasis. The non-loss and non-energetic relative to the active passive. So these three concepts are relative. For the active passive, we judge the energy larger than 0 always. But for the resistive network, energy for common network, we can judge power larger than 0 for resistive network. For the non-loss, we judge energy equal to 0. For the non-energy, we judge power equal to 0. The any time equal to 0. For the reciprocal, we judge the Z or the Y parameter, the symmetry. For the linear, nonlinear, we assume U1, I1, U2, I2. Then we judge the alpha U1 plus beta U2 and alpha I1 plus I1 beta I2 are still solution. For the time invariant, we judge U1T, I1T is solution. Then we judge U1 delay, T delay, and I1T delay is still solution or not. This is a basic concept. And then we discuss the basic components. R, L, C, M, LCM. And for any kind of components, we have 4 types. For the R, we have current control, and we have voltage control, and we have monotonous, and we have the multi-value. 4 types. RLC, this is for the nonlinear resistor. We have 4 types. For the nonlinear inductor, capacitor, and memorator, we always have 4 types. And then we have discussed how to judge a common 2-terminal component, active or passive. For the RLC, if the larger than 0, so is passive. If less than 0, it's active. This is for the common 2-terminal. The memory is the same. This passive active judgment. And for the US, IS, and the dependent source, they are always active. all is active. And then the OPA, operational amplifier, are always active also. For the transformer, it should be passive, non-loss, and non-energetic. And for the US and the IS, depending on the USS, the voltage source, current source, they are not independent components. For the US, we can treat it as a resistor, nonlinear resistor, or we can treat it as a capacitor also. Capacitor. For the IS, we can treat it as a resistor, and we can also treat it as an inductor. This is the voltage source, the current source. This is the total content of this chapter. Now we discuss the last chapter of this course, nonlinear circuit. For the nonlinear circuit, we will discuss the nonlinear resistive circuit at first, and then we'll discuss nonlinear first order circuit, and then discuss the nonlinear second order circuit. For the nonlinear resistive circuit, I think you should have learned in the undergraduate course. It's very simple. So we will introduce it faster. At first, we introduce the nonlinear resistive circuit. And we will introduce the gyro point calculus, operational point, transfer function, and the small signal analysis, segment linear, and the assumed state method. And then we'll discuss the first order nonlinear circuit and the second order nonlinear circuit. Gyro point figure for nonlinear resistor. This is a common nonlinear resistor, and the international figure is this. This is nonlinear resistor. We have introduced 4 types: the current control, the voltage control. This is the current control. This is a voltage control. This is one kind of the voltage control resistor. Actually, it's a diode. It's a special diode. The monotonous means it can use plus as a voltage control or the current control at the same time. For the comment for this resistor, the multiple value. For the example, this is 1 voltage, have 2 current, have 3 current. This is 1 current. This is 1 current. Has 1, 2, 3 voltage. We call this multiple value. For this 3-terminal network, we can treat it as a resistive network also. We can treat it as a 2-port network. If the U and I relation, if the relation have no differential, we treat it as a resistive network. For the static and dynamic resistor, this is a concept. At any worked point P, the static resistor means at the point P, we just use a U over I. The dynamic resistor means at the point P, the U differential to current I. For the example, at this point P, if this point U, this point I, this point U 就碰到 U。The U over I is the state register. State register. If the differential means this line. This line, this differential line. This line is the differential. For the monotonous register, in this case, the dynamic register larger than 0. Dynamic register larger than 0. And sometimes we can find the dynamic register will less than 0. The static register means U over I means this alpha tangent alpha. The dynamic register means U differential to I is this tangent beta. Tangent beta is here, this beta. The static and dynamic capacitor or inductor have the same meaning. And repetition, the static and dynamic resist will change with work point, so it's not a constant. The static means the U-I relation. The dynamic means how the U change with I. How U change with I. So it's differential. du di. For the S-style and the N-style components resist the descendant segment. That means this segment, and this segment. When we calculate the du di, we will find the RD less than 0. That means the voltage increase. This voltage increase, but the current decrease. This increase, but the current decrease. So du di less than 0 in this part and this part. The voltage increase, the current increase also. This voltage increase, current increase also. For linear capacitor and nonlinear capacitor difference. Pay attention for this figure. This figure means a capacitor, a common linear capacitor. But this arrow means the capacitor. We can change the capacitor. It's adjustable. Capacitor. But this figure, this is a little difference. This is difference with this figure. This means nonlinear capacitor. This is nonlinear. This means adjustable. But the common radial circuit, this is a radial circuit. Common radial circuit, we change this capacitor to adjust the resonance. So it can change the radial frequency. But for the nonlinear capacitor, we don't change the capacitor here. We change resistor here, change the voltage source here, change this here, the source. This source changed. That means work point changed. UC1, UC2. So if we change this DC source, the work point changed. When the work point changed, the static capacitor and dynamic capacitor will always change. Change the UO, then change the static capacitor and the dynamic capacitor. So this is a difference between the linear and the nonlinear capacitor. Now for most digital radio, so always use this method to change the dynamic capacitor. For nonlinear resistor circuit function, we use KCL, KVL, and the VCR to solve. We can simplify the circuit linear part. For the nonlinear part, make it at the outside. For the linear part, we can use Thevenin or Norton's law. For example, if the circuit with only one nonlinear resistor, we can treat the linear part as a Thevenin circuit. So this linear part, then the circuit will be simple. Then it will be easy to calculate. The standard method, the node voltage method, the loop current, and hybrid method. If all branches are voltage control, we can use the node voltage method. If all branches are current control, we use the loop current method. If some are voltage control, some are current control, we use hybrid method. The general form will be like this form. And for the DC circuit, there will be no time t. So it will be FUI equal to 0. But this will be nonlinear function. FUI equal to 0. Maybe U square plus 3U minus 4 to 0. Maybe like this. Or minus I to 0. We call the solution as static work point. The solution method, the figure show method, just use the figure to estimate the solution. The several drive point, transfer function, and the work point, and sometimes we use numerical analysis. This means use computer to calculate. It's suitable for computer to calculate. This is a segment method. The drive point calculation. For example, the drive point means this point, U and I relation. We call it as the drive point. The port voltage and the port current relation. We try to calculate U and I relation. The transfer calculation means maybe we discuss this U1, U2 relation, or I1, I2 relation, or this U1, I2, or I1, U2 relation. We call this transfer. The transfer means the different position, the response, and the stimulate located in different position. We call it as transfer. If they're in the same position, we call it as a drive point. So this U and I are in the same position. These variables are in different position. We call them as transfer. For the work point, the solution of nonlinear circuit. Sometimes there are only one solution. Sometimes there are several solutions. And sometimes there will be infinite solution. Or sometimes no solution. This means the model is not accurate enough. We should modify the model. If the circuit have infinite solution or non-solution, means the model is not accurate. For example, assume this is 10 watts, this is 10 watts. This is 10 ohm. So this current will be I equal to 1 ampere. But this I1 and this I2, so I1 and I2 will be infinite solution. We can make only I1 plus I2 is 1 ampere. Then it's okay. Maybe I1 is 0, I2 is 1, or I1 1, I2 is 0, or 0.5, or minus 0.5, 1.5 are all okay. So for this circuit, the solution is infinite. The infinite solution means the model is not accurate enough. For the for the actual circuit, there should be a resistor here, because any source will have resistor. This source will have resistor also. This RS1, this RS2. So if with these two resistors, the I1 and I2 will have only one solution. So for this case, we should change the model. The driver point and transfer current. When zero connect nonlinear circuit. When zero connect means the same current is the same. But the voltage is the sum. So this current, this voltage. So this will be add the U1, U2 code, get the U code. From every current add the voltage, we got the new driver point code. For the nonlinear resistor parallel, the parallel means the same voltage, but add the current. This is the voltage, this current, the same voltage, add the current. So get the new driver point current.